The past decade has seen some of the warmest years on record. In response to climate change and extreme weather patterns, several governments and businesses have committed to net zero emissions targets by the year 2030.
There is an urgent need for energy transition due to energy security has an impact on quality of life, health and education. We need to make sure that energy supply is secure, sustainable and affordable for the future. We see that the energy sector is evolving to reduce its carbon footprints, and they are doing that by increasing their investments in renewable energies, energy optimization solutions, as well as carbon capture and storage. And this is of course driven by the climate change and mitigation efforts, as well as the quest to preserve natural ecosystems.
As the energy sector evolves to meet sustainability goals, there is a growing need for technologies that will allow it to continue producing with as low of a carbon footprint as possible.
We want to share responsibility by reducing our carbon footprint and develop technologies that meets the global climate change goals, such as the Paris Accord, and we will need to do that in a safe manner as possible.
Well, it's important to understand what is going on in the oil reservoir in order to improve the oil recovery, produce oil in a more safe and cost-efficient way. So what we deliver is data that are used by reservoir engineers to optimize production of oil and gas.
Conventional technology are being repurposed for the energy transition. It is imperative to collaborate, develop technology that reduce both cost and risk, thereby enabling the alternative energy source to be viable. True innovation comes from diversity in thoughts, diversity in perspective, and cross-industry approaches, connecting the brightest mind and encouraging them to develop transformative idea and solution.
For years, energy producers have focused on ways to drill deeper, safer, and more cost-effective wells. As technology advances, an increased knowledge and understanding of the reservoir are becoming key to true efficiency and effectiveness.
CCUS and geothermal need understanding of the subsurface because CO2 and water flow is determined by underground pore and fracture space. And knowledge of this underground space is key for efficiency and safety. So for carbon storage, we want to avoid damage to the subsurface, and we also want to avoid leaks to the surface. And for geothermal, we want the fluids to connect as efficiently as possible to hot rock when the water is flowing.
As a global population, we emit CO2 into the atmosphere, which accelerates global warming. CCS technologies allow us to capture that CO2 at source and even from the atmosphere. It's therefore essential that we develop technologies that allow us to properly verify that we've captured that CO2 and stored it, and track the migration and movement of that CO2 over time.
Today, organic tracer technology reduces subsurface uncertainty by providing proof of mass transport in the reservoir, production, carbon storage, and geothermal domains.
The basis of tracer technology is tracking fluid using tiny but resilient and stable organic molecules. These molecules are unique and countable in very small quantities using advanced lab measurement technology. We can count them 1 million times more sensitive than your average airport security swab. Because most of the subsurface is unknown to us, decisions related to it are based on advanced models. Models are just advanced guesswork until you add information from real physical measurements. And when tracers are injected and carried by natural flows in the reservoirs, they create a direct measurement of flow connections and the magnitude of such flows. Using this information when you build and update a model can turn the model into a very useful tool to make decisions and test scenarios before you make decisions.
As the only proof of mass transport across the reservoir, tracer technology is critical to efficient extraction of oil and gas, as well as to ensuring that carbon is safely captured and permanently stored.
Tracers simply travel with the targeted fluid without affecting the flow and without being affected by the rock. So therefore, we can observe and quantify the movement of the fluid directly from the tracers. As an example, if you inject 10 kilograms of tracer and you find 1 kilogram at the outlet, you know that 10% of your flow went from the injection point to the extraction point. By measuring the tracer response over time, we can also find the time it takes to reach a specific location. And if you link that to the injected rate, this time then gives you the volume filled up by the fluid tracked by the tracers on its way from the inlet to the outlet.
Creating a unique fingerprint The tracers are specifically designed to identify target fluid or gas in a way that is safe and non-invasive to the storage environment.
The key to unlocking geothermal energy is to understand the flow of water through the subsurface in extremely high temperatures. Resman's tracer technology provides a stable, reliable and accurate signal even at these temperatures. Our high-resolution data allows you to quantify the reservoir characteristics.
Overcoming the limitations of traditional methods, the technology can handle an extreme operational envelope without intervention risk, delivering economic benefits, enabling a viable new energy future.
Today, most geothermal projects are in the vicinity of the hottest parts of the Earth's crust. Technology will allow regions not previously considered to be developed for geothermal anywhere. What we're likely to see is deeper reservoirs, larger scale projects leading to more power that become commercially viable that will then promote incentives and investment around the globe.
We have been able to successfully transfer our learning and core to the renewable space. And it turns out it's enabled us to reduce operation risk by utilizing the natural energy of the reservoir and fluid flow to replace power and communication, enabling us to get a direct physical understanding of the reservoir and how they move. So this can easily be applied across sector, whether we're talking about oil, water, gas, CO2, and siderate.